Alright, to start out our test review, you need to remember how centripetal force works. Centripetal force causes an acceleration toward the center of the circle. That acceleration is velocity squared over radius. And so we can say centripetal force is mv squared over r. Centripetal force is the net force. It is not a force on its own. It is the sum of the forces in and out of the circle. So the sum of the forces, the net force, is mv squared over r. Centripetal force is not a force. It is a sum of forces. And to find that sum of the forces, you do in minus out equals mv squared over r. In some situations, it's very easy. Say we have a vertical circle, so moving up and down, in which gravity is pointed out here at the bottom, and tension, whatever's holding that thing moving in the circle, pointed in. So we would have tension minus weight equals mv squared over r. And then separately, when that object is at the top of the circle, we have tension in and gravity in. And so in that case, we would just have tension plus weight equals mv squared over r. Now this gave some people problems in the flying pig lab, because in that lab, you had a pig flying in a horizontal circle, and a lot of people were trying to put gravity in, but gravity is not pointed in or out of the circle. Gravity is pointed down, and that's perpendicular to the circle. It can't be either in or out. The only force here was part of the tension, so the tension pointed this way, and therefore the y component of the tension was what pointed into the circle, and that was your only force. So in that, it should have been Ty equals mv squared over r. And you had to use trigonometry, sines and cosines, to figure out Ty. That's how you did that. So there will be a lot of situations like the simple, you've got a vertical or horizontal circle, decide what forces are in and out. But also it is possible that you will have forces that are neither in nor out, and so you do have to think about that. However, in a lot of situations, like you might answer on a multiple choice part, they're probably going to be the simpler, all the forces fit into in and out, but be aware that you could get thrown a question where a force is not an in or an out force. So you just got to do some extra thinking. Does this force really point in or out? Just think about it. Alright, here's an example problem we solved. A ball on the end of a string revolved at a uniform rate in a vertical circle of radius 72 centimeters. If its speed is 4 meters per second and its mass is 0.3 kilograms, calculate the tension in the string when the ball is at the top and when it's at the bottom. Why don't you pause the video and try this problem, and then I'll have the answers when you come back. So go ahead and pause the video. Pause it. Pause it. Okay, here are my solutions. I'll talk through them real fast. At the top, in minus out equals mv squared over r. Tension and gravity are both pointed in at the top per my free body diagram over here. Both pointed toward the center. So I can solve for tension. Tension equals mv squared over r minus fg. Plug in the numbers for tension, and if we have a mass of 3 kilograms, our weight is 3 newtons. So plug that in for fg. Solve it out, and you get 3.67 newtons. At the bottom, I didn't draw a free body diagram. Let's do that real fast. Should have done that. Would have cost me a point on the AP exam. Tension up, weight, or mg or fg, whichever one you want to label it as. We've generally done fg. I should probably leave it that way. Down, tension is the in force. It's pointed in toward the center. Weight's pointed out, so T minus Fg equals mv squared over r. Solve for tension. T equals mv squared over r plus 3 newtons. Now, according to this problem, the speed doesn't change. Nothing's going on there. And so we can take our tension and plug it in here. Add the 3 newtons, we get 9.67 newtons. Sorry, not take our tension. Take our mv squared over r. Plug that in, since m didn't change, v didn't change, r didn't change. All the same. So we know that's going to come out to be 6.67 newtons. Just add the 3, we get 9.67 newtons. Alright, remember that we can also have a situation with a banked turn where it is not, if a car is going in a horizontal circle, it is not friction that provides the centripetal force, but rather part of the normal force, in this case n sine theta, if theta is measured from the perpendicular on the road. And better yet, if theta is the angle of your bank, so how much the road is tilted, if theta is how much the road is tilted, then the normal force that gives the centripetal force is n sine theta. And you could work out those angles, but basically if the theta is how much the road is tilted, then n sine theta is your normal force. If that seems weird, you're like, wait, why would that always be true? Don't worry about it. Every time, just draw the picture and set up the angles and figure out what's pointed in toward the circle. So in this case, we know the in toward the circle would be the y component. That y side is opposite the angle. And so we use sine because it's opposite the angle. Remember, on a banked turn for a car, friction is not required. You can just use the normal force. To close out this part of the review, I want you to try this question. The answer's already on there. Work at it until you could get the answer, so you're going to need to pause this slide. If you can't figure it out, call a friend, call me, get the answer. But try this problem. Pause the video if you need to. Pause it. Pause that. Pause it. Try this problem.